Alright, so here's a couple of fairly short examples from Chapter 5. We want to find the first 5 terms to the Maclaurin series to the solution for the following IVP. So we have y double prime plus x squared y prime plus sine of x times y equals 0, with y of 0 equals 1 and y prime of 0 equals 1. And so what this means, right, is that we want y double prime of 0, y triple prime of 0, and the fourth derivative at 0, right? Because that'll give us the first 5 terms. Remember that the first term of the Maclaurin series is just going to involve the y of 0. Okay, good. So yeah, our first 2 terms, we have our y of 0 and our y prime of 0. So now we look for our y double prime, and that's equal to minus x squared times y prime minus the sine of x times y equals 0. And now if we plug in x equals 0, we get that y double prime of 0 is equal to minus 0 from our x squared, and then minus or times y prime of 0, which is going to be 0. So minus 0 equals 0. Okay. Now, to find y triple prime, we just differentiate everything in sight. And the main thing you just want to remember is that those are product rules, right? So we're going to have minus, and then we just use the product rule, 2x y prime plus x squared y double prime, right? Minus, then another product rule. So that's going to be cosine of x y plus sine of x y prime equals 0. Good. And then we look for y triple prime of 0. 0, 0, minus y of 0, right? And so y triple prime of 0 then will be minus 1, it looks like. Good. And now for the fourth derivative, you just have to differentiate again. So, it's going to be a long expression, but we just differentiate piece by piece. Each piece uses the product rule again. So let's see, derivative of the first one will be 2y prime plus 2x y double prime. And then the derivative of that one will be 2x y double prime plus x squared y triple prime minus, and then our cosine of y be minus sine of x y plus cosine of x y prime plus cosine of x y prime plus sine of x y double prime. Am I going to fit it in there? And then all of this is equal to 0. And notice this is a really long expression, but notice that we're just plugging in 0. And so y to the fourth 0 is just going to be, that's 0, that's 0, that's 0, that's 0, that's not, that's 0. Okay, so we end up with just minus 2y prime minus 2y prime equals minus 4y prime. And y prime of 0 was 1, so that's just going to be minus 4. Good. All right. So now we have all of our coefficients. Let's see, y of 0, let's just write them down here. Y of 0 equals 1, y prime of 0 equals 1, y double prime of 0, was that 0? Yep. Y triple prime of 1 was minus 1, and y4 at 0 is minus 4. Good. And so therefore our y of x is going to be 1 plus x plus 0 minus 1/3, 1 over 3 factorial, x cubed minus 4 over 4 factorial, x to the fourth plus higher order terms. Good. You could leave your expression like this, but notice that 4 over 4 factorial is the same as 1 over 3 factorial, or 1/6. So you could also write that. Very good. So this is our solution. Now you might say, well, there's only 1, 2, 3, 4 terms, but 0 we're counting as one of the terms, so you can count 0 as a term in your expression. Okay, good. Now, let's try another one. So that was the method of derivatives. Let's use the full method now. Y double prime, 2y double prime, plus x plus 1, y prime, plus 3y equals 0. But now our base point is equal to 2. Alright, so notice that means that your y is going to be x minus, in powers of x minus 2, right? Alright, so now let's go ahead and just plug it all in and see what we get for our recurrence relation, and we'll stop at the recurrence relation. Okay, so we get 2 times the sum, n equals 2 to infinity. After a while, you kind of get used to these. Doesn't take too long. Okay, so there's the second derivative. Plus x plus 1 times the first derivative. N a sub n, x minus 2 to the n minus 1, plus 3 times our sum, n equals 0 to infinity. A sub n, x minus 2 to the n. And all of that's equal to 0. And again, remember our goal way down here somewhere is that we want the sum times x minus 2 to the n equal to 0, right? Because then you set your coefficients equal to 0 for each n, and that gives you your recurrence relation. Good. So you might be seeing the problem here, right? And so what do I need to put in here in order for this to work? I need an x minus 2, so instead of x plus 1, I'm going to rewrite x plus 1 as x minus 2 plus 3. And so that'll make this actually two sums, and so my two sums will be x minus 2 times the sum, n equals 1 to infinity, n a sub n. Let me be very explicit here. And n a sub n, x minus 2 to the n minus 1, plus sum, n equals 1 to infinity, 3 n a sub n, x minus 2 to the n minus 1. Okay, and then this one's still there, and this one is still there. Okay, and now notice that this one becomes n a sub n, x minus 2 to the n, and then this one I'll just go ahead and bring it down to 3n a sub n, x minus 2 to the n minus 1. And then let's go ahead and bring in our last term down below here, because we're just about ready to go. 0 to infinity, 3an times x minus 2 to the n. And then our first term was 2 times, let's go ahead and bring in the 2. Sum, n equals 2 to infinity, 2n times n minus 2. That's an n minus 1. A sub n, x minus 2. I'm just trying to squeeze it in there. Sorry about that. Now I need some space. Good. And now we check to make sure that everything is starting on the same power. Oops, that's an n minus 2 there. Let's see if I can write that without losing you. Good. Okay, so this starts with a 0 power if I plug in n equals 2, right? This starts with an x minus 2 to the n power. That's not a typo, right? And so I can go ahead and just start this at n equals 0, right? And that, because of this front term, that's not going to change anything. Good. And then this one starts with an x minus 2 to the 0 power, and this one starts with an x minus 2. Good. And so now we're ready. I'm going to let k equal n minus 2, or n equals k plus 2 in this first one. And then for this one, we'll have k equals n, or n equals k. And for this one, we'll have k equals n minus 1, or n equals k plus 1. And then this one will be n equals k, or k equals n, either way. Very good. Okay, and now we just write down our, now we can bring the sum together. Oops, now we're working with k equals 0 to infinity. So this first one is going to be 2 times k plus 2 times k plus 1, a sub k plus 2. Okay, this next term then, so that's finished. That finishes that first one. The next one is going to just be k a sub k. Okay, plus, so that finishes that one. 3 k plus 1, a sub k plus 1, finishes that one. And the next one will be 3a sub k. Good. X minus 2 to the n equals 0. And so this now gives us our recurrence relation. You always solve for the last one here, a sub k plus 2. So a sub k plus 2 is equal to minus, bring the a sub k's together. Then we have our, I'm going to put the minus out in front here. Then we have our 3k plus 1 times a sub k plus 1 divided by k plus 2 times k plus 1 times 2. And there you go. That is the recurrence relation for the problem. And then we can stop there. Good. Yeah, so although it does get a little bit long, it's pretty straightforward, I think. So we'll see you later.